So question number 5 gives me a kind of complicated function, but it gives me the graph. It says the graph is shown below. Find the largest value of a. So basically, where do I need to cut this function off so that it will have an inverse? So x is less than the value a, so this half has to have an inverse. Well, what I know is to have an inverse, the original function has to pass the horizontal line test. Well, since we know we're going this way, it would pass the horizontal line test until we get to this minimum. After the minimum, it would wrap back around and no longer pass the horizontal line test. So basically what this is saying is, what is the minimum of the function? Well, to figure out the minimum of the function, I'm going to take the derivative. E to the 2x becomes 2e to the 2x, 6e to the x becomes 6e to the x, and 5 goes away. So I want to know where that's equal to 0. So first I factor off 2e to the x. If I do that, that gives me e to the x minus 3. 2e to the x is never equal to 0. E to the anything is never 0. So I get e to the x minus 3 equal to 0, so e to the x equals 3. If I natural log both sides, that means that x value is the natural log of 3. The natural log of 3 is the x coordinate of this minimum. That means that if I go up to that value, it will pass the horizontal line test and we will have a minimum. So that is my a value, the natural log of 3. Part B of the question says, for this value, find an expression for the inverse. So this is not really a function I can take the inverse of because it has multiple locations for x. It's going to be really hard to solve. So the first thing I did is complete the square to make it a more invertible function. So I first disguised it. I said y equals u squared minus 6u plus 5. So if it's y equals u squared minus 6u plus 5, I'm going to complete the square on this. That's going to give me u squared minus 6u plus 9 plus the 5 we already had minus 9. These two numbers weren't there. They cancel out, so we haven't changed the original function. This becomes u minus 3 squared. This becomes minus 4. So now I have a different version of this function. It's a function that I'm going to be able to take the inverse of because x only appears in one place now. So what we're going to do, the main thing to remember about an inverse, switch x and y. So instead of y equals, we now have x equals e to the y minus 3 squared minus 4. Solving this out, basically all I'm going to do is add 4, square root both sides. When I square root both sides, it becomes plus or minus. Then I'm going to add 3. To get to y, I'm going to natural log both sides. So y is equal to the natural log of 3 plus or minus the square root of x plus 4. Now, what we knew from the original problem, and this is where the domain where the value of a comes in, we know it has to be less than the natural log of 3. Well, this would be the natural log of 3 if this were gone. So adding that is going to make it bigger. Subtracting that is going to make it smaller, so the only one that works is the natural log of 3 minus the square root of x plus 4. Now, for the domain, it's relatively simple. This is the inverse, so if we look at our original range from negative 4 inclusive to 5 excluded, that's going to become the domain of the inverse. They simply switch.